I'm Anil Kumar, and here is an excellent identity to prove. Prove that cot square x divided by cosecant x plus 1 equals to cosecant x. Now I'll take this opportunity to also remind you of Pythagorean trigonometric identity, which relate cot square x with cosecant square x. So I'll actually provide you the proof of that once again here. We have done it elsewhere, but I know most of the students do not really use it, so it is very helpful. So let's derive that. There's no harm. Let's say this is angle x, and we have a right triangle here where the sides are a, b, and c. Now using Pythagorean theorem, we can say a square plus b square is equals to c square. We want something with cot and cosecant, right? So as you know, cosecant is c over a and cot is actually a over b, right? So cosecant, sorry. Now as you know, we really need a relationship between cot and cosecant, and cot is a over b and cosecant is c over b. So it is divided by b. So if I divide this by b square, what happens? Well, this is a standard way of proving Pythagorean identities, and some of you, for some of you it might be new thing, but I hope you appreciate it. A by b is what for you? A by b is actually equals to cot, right? So I can write this as cot square x, and b square by b square is 1. C by b is cosecant, right? So I can write this as cosecant square x. So in a way, we have this identity right there, which is cot square x plus 1 equals to cosecant square x. So I'm going to use this identity in proving the given trigonometric identity. Well, if you don't want to use it, then a very simple solution here is that you can write cot and cosecant in terms of sine and cosine, correct? Start with the left side, you will land up with the right side, correct? So that is the way. But I'm going to use it and show you a shorter way of doing it. It saves a lot of time. Once you know, you don't really have to prove it. It's an identity just as you use cos square x plus sine square x equals to 1. And you also use 1 plus tan square x equals to secant square x, right? All have the same derivation. The only thing is, once we divide by c square, once we divide by a square, and this time we are dividing by b square to get these identities. I hope you appreciate this concept. Okay. Now let's begin with the left side. We'll take common denominator, and this time the common denominator for us is cosecant x plus 1. The numerator is cot square x plus, we'll multiply this by 1, so we get cosecant x plus 1, right? Now as you know, cot square x plus 1 is how much? Cot square x plus 1 is cosecant square x, so we can write this as cosecant square x, right? Cot square x plus 1. So what we have done here is combine cot square x and 1. So what we are left with is plus cosecant x, right? In the denominator, we have cosecant x plus 1. Now in the numerator, I can take cosecant x common. So we have cosecant x plus 1, right, divided by cosecant x plus 1. Now cosecant x plus 1 gets cancelled, so we get cosecant x, which is equals to the right side, right? So that becomes a very simple proof. You can also do this proof by writing cot and cosecant in terms of sine and cosine, but I hope this is neat and far better. So adopt this kind of approach to solve all trigonometric identities which involve tan, cotangent and all, right? You have been using only this identity amongst the Pythagorean identities. I'll encourage you to use these two also whenever permitted, right? So I hope that helps. You can subscribe to my videos and learn a lot. Thank you and all the best.